So students, we are going to discuss short questions of chapter 8, which is waves, in just 5 minutes. So let's start. What features do longitudinal waves have in common with transverse waves? Both are mechanical waves, both transfer energy without transferring matter, and both obey the relation V equals to F lambda. Is it possible for two identical waves traveling in the same direction along a string to give rise to a stationary wave? No, it is not possible because stationary waves are generated when two identical waves move in opposite direction in the same medium. A wave is produced along a stretched string, but some of its particles permanently show zero displacement. What types of wave is it? It is a stationary wave, and these points are known as nodes. That means the points which show zero displacement are known as nodes. Explain the terms crust, trough, node and antinode. The upper portion in a transverse wave from mean position is known as crust. The lower portion from mean position in a transverse wave is known as trough, and the point which shows zero displacement in stationary waves are known as nodes, and the points which show maximum displacement in stationary waves are known as antinodes. Why does sound travel faster in solids than in gases? Because in solids, atoms and molecules are more close to each other than the gases and hence respond more quickly to a disturbance. That is why sound travels faster in solids than in gases. How are beats useful in tuning musical instrument? When we plug the string of the musical instrument against a note of known frequency, then beats are generated. Then we tight or loose the string of the musical instrument such that no beats are generated. Hence we say that musical instrument is tuned. As a result of distant explosion, an observer senses a ground tremor and then hears the explosion. Explain the time difference. Because sound travels faster in solids than in gases, that is why time difference occur. Explain why sound travels faster in warm air than in cold air. We know that speed of sound is inversely proportional to the square root of density, as if density is smaller, then the speed of sound will be higher. And we know that density of warm air is smaller, that is why speed of sound is greater in warm air than in cold air. How should a source and sound move with respect to an observer so that frequency of its sound does not change? If relative velocity between source and observer is zero, then frequency of the sound will not change. So hopefully you have understood all the short questions, and if any one of you have an issue, then listen it 2 to 3 times and try to speak or communicate in English. Definitely you will learn very soon.